So here we want to find the vertices and locate the foci for the hyperbola with the equation x squared over 25 minus y squared over 16 equals 1. Where when we're looking at these equations, determining, I guess the way you want to talk about it, opening, either horizontally or vertically, can be seen as which of the two terms is written first. Sometimes when we talk about these things, you'll get them written in the opposite direction, but the standard form always has the positive one first and the negative one second, where in this case in particular, we don't actually always have that A is bigger than B because A and B don't have that same kind of relationship that they did for ellipses. However, in this case, noticing that we have X first, that means we're going to be looking at this in terms of horizontal openings, in terms of horizontal positions for the vertices and the foci, where to find these values, we can start by noticing that for this, A is equal to the square root of 25, or meaningfully 5. And we have the horizontal orientation with our transverse axis along that horizontal axis. Similarly, we have the not quite as meaningful value of b here, where b is equal to the square root of 16 or 4. And then if we want to get c, c is going to be equal to the square root of a squared plus b squared, so 25 plus 16, or the not so nice value of root 41. It's actually somewhat rare that our value c ends up being kind of nice, at least if we're starting from kind of nice places for a and b. For the same reason that we don't always get nice hypotenuses. Hypoteni? I'll have to look that up. But for the same reason that those relationships don't always come to clean places, c for hyperbolas is not always going to be a clean value, but here this ends up being something in the neighborhood of 6.5. Anyway, from this, we get that our foci are going to be at plus or minus c0, so plus or minus root 41, 0, while the vertices are going to be at the A type of value, which here is going to be plus or minus 5, comma 1. And it's important to remember that with hyperbolas, the foci are always a little bit further out than the vertices. But we've got our foci, and we have our vertices, so if we wanted to get a sense of what this looks like, we'd end up with a picture something like this, where for now, don't worry too much about where this comes from, because we're not at the point of being able to make a nice graph just yet. It's a bit of a complex set of steps, but at the very least, we should know roughly that this is what we're looking at. And next, we're going to get one more example with this kind of construction, just, let's say, turned a bit on its head. For this example, we want to find the vertices and locate the foci for the hyperbola with the equation y squared over 25 minus x squared over 16 equals 1, where we should notice again that in this case, we have that a is equal to the square root of 25 or 5, b is equal to the square root of 16 or 4, and c is equal to the not so pretty square root of 41. But because we are attaching that value a to y first in this case, we have the flipped over vertical arrangement instead. That is, when we're talking about our foci and vertices, our foci are going to be positioned in terms of vertical movement. That is, they will be at 0 plus or minus root 41 this time, while our vertices will similarly be rearranged vertically and end up at 0 plus or minus 5. So if we wanted to get a picture just to understand what this is going to look like, we'd end up with something very similar to what we got last time, just like I said, a little bit spun. But that's essentially the process for being able to identify those basic parts, the foci and the vertices that we're going to talk about being able to use to build our hyperbolas. Next, we'll get one more example here just to really fill in as many details as possible going in the other direction. So for this example, we want to find the standard form of the equation of a hyperbola with foci at 0 plus or minus 5 and vertices at 0 plus or minus 3. So again, remember that the vertices are always going to be inside of the foci, as it were. And in this case, we have foci and vertices in terms of the y-coordinate. So because of the arrangement we're working from, our goal is going to be to get something of form y squared over a squared minus x squared over b squared equals 1. So what we need to do is find a and b, where a is implicitly given by the positioning of the vertices. That is, a is equal to 3 because our vertices are 3 away on either side from the center, while c is going to be equal to 5 for the same reason except in terms of the foci. And as a result, if we want to get b, that is going to be equal to the square root of c squared, 5 squared, minus a squared, or 3 squared, which here will end up being 4. So if we want to take all of this information and put it together to get our equation, we're going to have y squared over a squared, where since a is 3, a squared is 9, minus x squared over b squared, where here b is 4, so that would be 16, is equal to 1. And notice that unlike with the ellipses, b doesn't have to be smaller than a. The determination of which is a and b isn't a matter of size, like it was there. It's simply a matter of which one has the negative hidden 1 in there, the negative coefficient on our x or y. That determines our orientation, whether we have a positive or a negative in there, not the size of what we're working with. And from here, hopefully we have a good sense of the basics of how these pieces work, and for that matter, work together. Next, we're going to talk about another property in terms of how these things look asymptotically, that is, how they approach but never touch certain values, and how we can use that to be able to graph our hyperbolas.